And Cantor created the proof to show that the set of all integers is equal to size in any given interval. But to understand this, we first have to talk about infinity. To give you a clear idea of infinity, this chart helps show us that there is no stopping point.
This brings us to the question we will try to prove using the sunshine proof. The question is, which is larger, the set of all integers or the set of all real numbers between 1 and 5? So in order to answer this question, we have to look at what exists in space. So looking at the interval itself between 1 and 5, what possibilities can we find in the interval? And in the interval, we'll be looking at real numbers, which can be any rational or irrational number. So for example, it can be a whole number like 1, or it can be a fraction like 1/2, or a decimal, or like the square root of 2. The other type of space that we need to look at is the space in the set of all integers. And to help us understand integers are whole numbers, and they can be negative or positive. So for example, -2, 0, and 6.
The sunshine proof uses correspondence to show the relationship between points in the interval and integers. For every point we use in the interval, we will correspond with an integer.
Approximately 10 hours later. A lot of boring math later. Thousand years later. One eternity later.
Returning to our original question about which is larger, we came up with the answer that they are equal. The sunshine proof helps us to use correspondence to show that the two sets, the set between 1 and 5 and the set of all integers, is equinumerous.